Hello everyone, welcome to Sri Chaitanya IIT Academy. Today we will be doing a very rapid analysis of the mains paper that held on 2nd of September, second shift. I will give you a brief introduction along with the areas and with the solution. I will help you with the solution. This session will be extremely beneficial for the aspirants of 2021 as well as the people who are going to appear in the test in this week itself, in coming days itself. So, very quickly move on to the questions. Let us see the first question. The first question here is from ethers, right, and again multiple questions has been asked here, right, multiple concepts has been asked here. If you see the question, the given compound has a molecular formula, this is given in the question, and it reacts with HI, okay, and it reacts with HI and it produces two compounds A and B, two compounds A and B. Now, they are talking about tests. Tests are very important. Please go through the test again and again. Now, A is going to give you a yellow PPT with AgNO3, that means it has to be a halide, right, and B shows positive iodoform test after tautomerization. So, tautomerization is also required, right. Now, iodoform test, for iodoform test what is required, that has to be kept in the mind. So, we will start with the first option that is given to us. Now, this is an ether and the reaction of ether with HX is important. Now, what is the reagent? The reagent is HI, and when I give HI here, right. Now, you should understand that HI is an acid, something like this, and this is going to give you H plus, right. Now, this H plus will look for electrons. Now, where do you find electrons? Of course, there are electrons here. So, this oxygen is containing electrons. So, this H plus will get protonated there. So, this is the first step that is going to take place, and after the protonation what you are going to obtain, please pay your attention here. This is the pH ring, I am using the short form, and this oxygen will get a hydrogen and only one lone pair will be left and it will bear a formal charge of +1 and rest of the things are intact. Now, what is the aspect, people? Oxygen with a positive formal charge. Now, oxygen whenever it will bear a positive formal charge, it is not very happy, it wants its lone pair back, right. So, it is a very good leaving group, it is a very good leaving group. Now, what do you have again? We have this particular thing, this is my nucleophile. Now, this nucleophile is going to attack, right, at the carbon. Now, this is the key, people. Which carbon it will attack? It will attack at sp3 carbon, it will attack at sp3 carbon, right. So, if it attacks from this side onto this carbon, right, and this bond pair shifts over to the oxygen, and this is how oxygen is going to regain the electron, right. And if it happens, what you are going to get? You are going to get this particular compound after the attack of I minus, and you are going to get an enol. You are going to get an enol, right. Now, we know that enol forms are not very stable, it will quickly undergo tautomerization, and you are going to get a aldehyde at this particular carbon. You are going to get a aldehyde at this particular carbon. Now, this aldehyde is going to give iodoform test. This aldehyde is going to give an iodoform test because of the presence of CH3 group. So, this is my B. So, this is my B, while this is my A, right. This is my A. So, this clearly gives you option number 1, right. In other options, you are not going to get the same product and they are not going to give you the iodoform test as well as the PPT with AgNO3. So, quickly we will move on to the next question. The next question that you see on the board is, again they are testing the knowledge of the directing effects of different groups in the benzene ring, right. So, they are interested in the directing effect of different groups in the benzene ring. So, let me use some different colors to show that for you. Now, this particular group has a plus H effect, right, as well as plus I effect. But if I forget all this and simply write down the directing nature of this particular group is ortho, para, directing, as well as it is activating, A for activating. Now what do we have for NO2 group? We know NO2 group shows minus M as well as minus I, and it is also what it is, an electron withdrawing group, so it is therefore deactivating. It is therefore deactivating. D stands for deactivating, right? And it is a meta directing group. At the same time, it is meta directing group. Now what else is left? We have a OH group as well. Let me use a different color for OH. Now this OH group has what? Plus M as well as minus I, but the plus M is more dominant. So again it is an activating group and the directing nature is ortho para directing. Now if you use this information and you sum up, right? So the directing nature comes here as an important factor in deciding the product. The overall product will be decided by the activating group and the stronger activating group. Now who is the stronger activating group here? Among all, we have this phenol as a stronger activating group. Now it will direct at ortho and para. So this is ortho. This ortho position is already occupied, so no possibility here, and we are left with this para position. Now if you compare, the ortho position is sterically hindered while the para position is little bit free, so the product will form at the para position and we were going to get the product third as my answer. What you have to remember, if there are multiple groups, you decide by the most activating group, and who is that fellow here? This is that fellow here. So quickly move on to the next question. The next question here is very easy and very simple. Again, a very basic question here has been asked. You see two reactions are given to you, 1 and 2, and they have given you the rates. Now here the rate factor, if you pay your attention, it is unimolecular, right? And in the second case, when you see, I think a K is missing here, there will be a K here. It will happen because we have collected these questions from the memory of our students, so there might be an error in printing 1 or 2. So please understand, there is a K here and this is bimolecular. This is what? Bimolecular. Okay. Now it becomes very easy. Let us look at statements one by one. The first statement, reaction rate of 1 remain unchanged if the concentration of OH minus increase, right? So let us look at the rate of reaction 1. This is my reaction 1. And you can see this is the rate, and we don't see the concentration of OH minus there, right? So with respect to OH minus, the rate is not affected for 1, right? So remain unchanged. Yes, it will remain unchanged. Yes, it will remain unchanged. So this is my correct. Now if you check for option 2, 3 and 4, they are incorrect. Why? Because rate of reaction 2, they are also saying unchanged if the concentration of OH minus increase. Now in 2 you see OH minus is present there. Now if you are going to increase the concentration of OH minus, the rate is going to get affected, right? So here my answer will be only 1. A very easy question from chemical kinetics, a very basic question from chemical kinetics as well as from alkyl halides. Next question please. When you see the next question here, again it's a very basic question. Every lecturer must include it into their lectures whenever they teach. Now you see here, they are simply asking you the acidic strength, right? So what is the general idea of Ka values, right? What is the general order of Ka values? The carboxylic acids are going to have a greater Ka, and after that if I am going to compare with alcohols and water, water is going to have a greater Ka, and again if I am going to compare with alcohol and alkyne, this is a terminal alkyne people, the terminal alkynes have a lesser Ka than alcohols. So I am going to use this information straight away in the question, and you see according to this question B is the most acidic H. B is the most acidic H. When you see B, where do we find B as the highest? We see at 2 option, 3 option and 4 option. So clearly people, I am going to strike off option number 1. This cannot be my answer. So in these kind of questions, elimination is a very important technique to approach. Now I have eliminated option number 1. I am left with option 2, 3 and 4. Now among these, when I have seen, please focus here, this is a printing error here, this is a triple bond. This is a triple bond, and as we have seen among alcohols, right, these are alcohols, alcohols have a greater Ka, so this one is expected to be the least. This one is expected to be the least. So where we are having it as a least? Option number 2. Option number 2. And by this only we can select our answer, that is second option is correct. Second option is correct. Let me move on to the next question. The next question here is basic question, and people pay your attention to this reagent. This is coming every year. Every year they are asking this question. This is beta elimination, this is E2, right? So pay your attention to this particular reagent. What is this fellow is going to do? This fellow is going to do beta elimination. Right. So this is going to do beta elimination. Now the option, we see the options, we have two possibilities. Now Sedgef alkene can be formed as well as Hoffman alkene can be formed. If they are not talking about any product which is major, which is minor, go for Sedgef. Go for Sedgef. Now for your comfortness, I am redrawing the structure again. This is my bromine and this is my fluorine, right? And I am showing you the beta hydrogens with a different color so that you can. Now with respect to this particular halogen, this hydrogen is your beta hydrogen, and with respect to this other living group, this is the beta hydrogen, right? Now the question is that which hydrogen is more acidic? The question is that which hydrogen is more acidic out of the two that I have shown here, and second is that who is the better living group. Now if you go for the electron withdrawing nature, the electron withdrawing nature of fluorine is more, so therefore this hydrogen will be more acidic, and at the same time bromine is a better living group, right? Bromine is a better living group. So what is going to happen? The OH minus, which is the base, is going to abstract this hydrogen. Why? Because it is more acidic, right? And what is going to happen, people? Please pay your attention. This bond pair will collapse here. And as a result, this is going to be kicked out. And you are going to get a alkene in between these two carbons, pi bond in between these two carbons with the fluorine intact. Where we have that? We have that here. So this is my answer. So here the key thing is that who is a better living group and which H is more acidic, right? So next question. This next question is very, very easy, right? Here what is important for you is that you don't have to pay your attention to the reaction and the products that are being formed. Rather you keep into mind what is the observation, what observation you are getting. That is more important. So sucrose hydrolysis, right? This is from your biomolecules, a very, very important chapter nowadays. Now sucrose on hydrolysis, you are knowing that what you are going to get A and B. Now what is A and B? This is glucose and this is fructose. This is glucose and this is fructose. Now glucose are aldoses, fructose is a ketose. Now what is this reagent? This reagent, there is a spelling error. Celi1 of reagent. This is nothing but resorcinol. Resorcinol, people, what is resorcinol? All of you know what is resorcinol. This one is called resorcinol. And along with this resorcinol, we also have acid. Then it is called that particular reagent. Now, when sucrose will be hydrolysis, you are going to get glucose, you are going to get fructose. Now, among glucose and fructose, fructose is going to react with this particular reagent. And when the reaction is done, you are going to get a red color. So the answer is this. But I am giving you the structure of the red color compound. And I am drawing it with red also. Right? Now, this is what you are going to obtain in the final product, and that is the color of this product is red. Now, people, don't pay attention to the structure, you don't have to memorize the structure, just you have to know the observation, what the color change will be, what color it will come, right. They are never going to ask you the structure of this particular compound, but for your comfortness I have discussed this. Now, sucrose on hydrolysis, you will get fructose, you will get ketose. Glucose is not going to react, fructose is going to react, and fructose will undergo dehydration into something like furfural, and that furfural is going to react with 2 equivalents of this reagent, that is 2 equivalents of resorcinol, and this particular this particular compound will be obtained, which color is red. Alright. So, next move on to the next question. In the next question, it is something interesting. This is one good question that I want to discuss with you, because here you see they are giving you a molecular formula. They are simply giving you a molecular formula, and they are saying this molecular formula is of 2 compounds, is of A as well as of B. Okay. So I am finding the DU. Whenever you see a molecular formula, people, the first step that you have to do is degree of unsaturation, right? And when you calculate the degree of unsaturation, you are going to get 1. So, keeping that in mind, what possible structures do I have here? I can have one structure like this, which is a ketone, or I can have one more structure as an aldehyde, right. I can have one more structure all of these structures have same DU, so I am including all the 3 structures in my discussion. Now, what they are saying, look into the question, A and B react with this particular fellow. Now, this particular fellow is Grignard, little bit correction is there, CH3 MgBr. This is Grignard, we all of us know. Now, when it reacts with Grignard, it gives C and D. Now, C and D have following information, right. C is giving your iodoform test negative, and D is giving your iodoform test positive. This is the information given here. And what they are saying, if you apply Lucas test, the positive result comes instantaneously with C. Now, this is the information provided. Now, please understand, people, what is going to happen with Grignard? This is the nucleophile, right? This is going to attack at this particular carbon, and finally you are going to get an alcohol at that particular carbon. So, I am drawing the product. And we are going to get a 3-degree alcohol. Here, on the other hand, I will get a 2-degree alcohol. 1 CH3 will come here, and this will become OH, and there is that hydrogen intact. Now, who is going to give you Lucas test instantly? Obviously a 3-degree alcohol, right? So, this is my C. Now, what about this one? This one is going to react with iodoform, because there is still a hydrogen left. And it can be oxidized. So, this particular compound is my D. Now, A is giving C, so this is my A, and B is giving D, so this is my B. So, everything is there in front of you, clear. But what about that last compound possibility? Now, this compound, when it will react with Grignard, with this particular fellow, that is Grignard, right, we will simply get methane, because Grignard is a base also. It's a nucleophile, correct, but before that it's a base. Now, in this particular compound we have acidic hydrogen. This hydrogen is acidic. So, it is going to react with that particular hydrogen, and you are going to get CH4, which is a gas. Now, this is not relevant with the information given in the question. So, we will simply not consider this particular compound. So, here is what you have in the screen, and if you closely observe the compounds C and D, they will be option number 2, right. So, next question here is from kinetics, chemical kinetics, and this portion what we call it's monitoring kinetics. The portion is called monitoring kinetics, people. Now, what is the situation? You have to observe this table. Now, when you observe this table, say for example, this is my rate, I am calling it R1. If this is R1, please pay your attention, what will be this one? This is 2 times R1. If this is 2 times R1, then people, what is this? This is 4 times R1. This is 4 times R1. So, that is important. Now, if you pay your attention to this particular reaction, then what is the rate? Law, expression, some K will come, concentration of A will be there, raised to power A. Let me take some other variable there, other variable, say for example, we take M here, and again concentration of B raised to power N, where M and N represents order. Right? If it is a complex reaction, then it is not equal to the stoichiometry, right? Now, you please pay your attention what you are doing from the first data. Here you can see when the concentrations are this particular values for A and B, we are getting the rate to be R1. Now, what you are doing, you are doubling the concentration of A. That means this value has been doubled. And the rate also became doubled. So, what is the key here? M is equal to 1. What is the key here? M is equal to 1. Now, again pay your attention and compare 1 and 3. Now, when you compare 1 and 3, you are doubling the B. See, B is 0.1 here and B is 0.2 here. You are doubling the B. And when you are doubling the B, you see the rate became 4 times. Now, when it can happen? When N is equal to 2, right. So, we have got the values of order, M is equal to 1 and N is equal to 2. Now, they are asking few more things, what is this X and what is this Y. So, I will classify it to be moderate to difficult, because you have to go that extra step. Here. Now, this can be concluded by writing the rate law at 2 different times. Say for example, you write down the rate law from this information available at 1. How you are going to write it down? The rate is, say for example, 6 into 10 to the power minus 3. This is the rate given. Now, you will put the K. We do not know K, but we know the concentration of A, that is 0.1. What is the value of M? We have already found out, it is 1. Multiplied by the concentration of B, it is also 1. What is the order of B? That is 2. We have just found it out, right? This is my equation 1. Now, what I will do, I will use this information and I will try to write down the same for this fourth information. This fourth information is going to give me what? 7.2. This is the decimal here into 10 to the power minus 2, and this is same as K. Now, what is the concentration of A? That is X. We need to find this X, right? And what is the concentration of B? It is this particular value, that is 0.2, and we will put a 2 here, right? Now, we simply divide them, and that's how we are going to get X. Now, again, if we want Y, we can use the information given in the fifth point, and we can write down the fifth point also in this particular way. What is the rate given? It is 2.88 into 10 to the power minus 1, and this is equal to some K times. What is the concentration of A given? It is 0.3 people raised to power 1. What is the concentration of B? We do not know. We have to calculate. This is Y. This is Y and this is 2. Now, we have, let us suppose this is my equation number 1, this is my equation number 2, and this is my equation number 3. So, you do what? You divide 1 by 2, you are going to get X. You divide 1 by 3, you are going to get Y. And when you solve it, you are going to get option number 2 as your answer, right? This is a very basic question and very important, and usually these kind of questions are asked. So, please prepare it very hard, right? Next question. The next question is pretty much easy and pretty much straightforward. Everybody must have done this question, right? Now they are talking about n equal to 4, that is the fourth shell, and they are also giving you the values of m, and they are asking how many subshells will have that particular value of m. Very easy. If the value of n is equal to 4, what are the permissible values of L? 0, 1, 2 and 3. 0, 1, 2 and 3, in which cases m equal to minus 2 is possible. It is not possible here, it is not possible here, it is possible here and it is possible here. So, we have 2 and that is my answer, right. Next question. Now, the next question is again from surface chemistry and pretty straightforward and pretty basic. Now, in this kind of questions people, whenever 3, 4, 5 statements are given, I suggest you go by elimination, because some statements you will never be confident, right. So, this is the best trick here. If you have studied this adsorption in the very first lecture of adsorption, you would have told 2, 3 things, right. First of all, this is a correct statement. This is a correct statement. Why? Because delta H becomes less negative with the progress of the reaction, right. You have been taught this. Then again we can see that C option is also definitely correct. Why? NH3 has more intermolecular force, hydrogen bonding can be there, right, if you compare with N2. So, higher the intermolecular force, greater will be the adsorption process. So, 3 is definitely correct, right. So, if you look at the option, C option has to be correct, then my answer can be either 1 or 4. I will simply reject 2 and 3. Now, if I do that, my probability of getting the answer correct is now 50%, right. So, therefore, elimination technique is always advisable in this kind of situation. Now, if you see this option number B, it is incorrect. Why? With the progress of the reaction, the strength of the residual forces, it does not increase, on the contrary, it decreases. Why? Because of this residual forces only the adsorption is going on. Now, if it goes on after some time, the residual forces is definitely going to decrease. So, from this logic, I will reject this option because it is incorrect, right. I will select the option number 1, that is A and C, my correct answer. Now, we will move on to the next question. The next question is again from periodic properties, again very factual and very basic. We know that left to right the strength of acidic nature of the oxides increases. So, that is what we have to see here. 3 elements are given, what are they? X, Y and Z, right, and such that the oxide of X is acidic, okay, oxide of X is acidic, right, oxide of Z is basic, and the oxide of Y is amphoteric, right. So, from this knowledge, where the element should locate? Suppose this is my third period, and what is my third period? Everybody knows the third period. Can we say it? It starts from what? Sodium, magnesium, and if you will move towards the right side, you are going to get aluminum, and then silicon, and then phosphorus, and then sulfur, and then chlorine, and then argon, right. So, as we move from this to this side, what happens? The acidic nature increases. So, therefore, this element has to belong to this side. Now, what about Z? It's basic. Now, these two are basic fellows. So, this Z should belong to this side. And who is amphoteric? Everybody knows aluminum, Al2O3 is amphoteric. So, they are talking Y. Y is nothing but my aluminum, right. So, atomic number from left to right, it increases. So, they are asking the order of atomic number. Now, who is going to be the lowest? Z is the lowest, right, and this one will write towards the right side. So, it will be the maximum, right, and in between we are going to have Y. So, you see here Z is the lowest, right, X is the highest, and that is my option number 1. Again, next question. The next question is also very simple, and it is a basic question from S block, right. So, what they are asking, 2, 3 things you can see: anomalous behavior of the first element of every group, that also is there, and other things are also discussed from S block angle. Now, they are talking about A and B, and they do not form solid bicarbonate. They do not form solid bicarbonate, but reacts with N2, to give what? Nitrides. Now, this line is the key to everything. If you pay your attention to this particular line, solid bicarbonate, see, only these bicarbonates are solid. Sodium bicarbonate, potassium bicarbonate, and this way you move down to cesium bicarbonate. Only these bicarbonates are solid. Now, what is this fellow here? This fellow is lithium. So, lithium bicarbonate is also not solid, but it is found in solution. And others, we do not get bicarbonates. So, first of all, from this information itself, I will reject option 2 because they form solid bicarbonate. I will reject option 3 because it also forms solid bicarbonate. I will reject option 4 because it also forms solid bicarbonate. So, from this information itself, the question is solved, right? And the second thing is that we have this nitrogen, they give nitrides. Yes, lithium reacts with nitrogen to give nitrides, as well as magnesium reacts with nitrogen to form nitrides. So, with the help of only the first option, we can get to our answer, right? So, quickly we will move on to the next question. The next question is again a very basic question from hybridization and vesiper of chemical bonding. You please pay your attention. The structure of SF6 is octahedral. Okay, we know that. What is the structure of SF4? Very easy, people. You can find out the steric number. What will be the steric number? The steric number will be 4 sigma bonds and 1 lone pair, that will give you 5. Now, when the steric number is 5, the hybridization that you will get is sp3d, and this hybridization will have a geometry something like this. 4 bonds, 4 orbitals will be in one plane and 2 orbitals will be perpendicular to this plane, one coming out of the plane and one going down the or inside the plane. Now, there are 2 different positions, as we can see. The purple ones are the axial positions and the red ones are your equatorial positions. So, there is a preference order, who is going to occupy the equatorial position. Now, we will place this lone pair in the equatorial position. We are going to place this lone pair in the equatorial position, and after that we are going to put the remaining fluorines in these positions, keeping the sulfur at the center. Now, when you look this one sidewise, sulfur is in the middle. This is my fluorine and this is my fluorine, and this is also fluorine and this is also fluorine. This looks like seesaw. Seesaw is the shape, while the geometry is TBP, trigonal bipyramidal, and they are asking about the structure. Now, by structure you can get to geometry also, you can get to shape also, but seesaw is not there, right? So, we will go for what? Trigonal planar. So, that makes my answer option number 1. So, quickly we will move on to the next question. The next question is again from metallurgy, very basic and very factual. You do not need to do anything. This is just an information. See, when we extract iron, we get pig iron, right? First spongy iron, then pig iron, which is dirty, then we get cast iron, then cast iron is upgraded to steel and wrought iron, right? This is the basic thing everybody knows, even a laborer knows this, right? So, it is a very basic line from metallurgy, and clearly the option is option number 1. So, next we will move on to the next question, question number 15. Now, this question is also very direct question. When you study and prepare coordination chemistry, you have this information that if a octahedral complex has all 3 bidentate ligands, then it is optically active. So, this is my octahedral complex. So, first of all, I am going to classify each of these complexes. This is my octahedral, right? This one will be tetrahedral. If you work on the process, you are going to get this one tetrahedral. This is square planar complex, people, PT plus 2 with 4 coordination number. It is square planar. Now, this one is also octahedral. Now, what is the next thing they are asking? The next thing they are asking is who is not going to show any kind of isomerism. Now, one by one. Just now I have seen that if it is an octahedral complex and we have all the ligands bidentate, all 3 ligands bidentate, then always it is optically active, always it is optically active. So it shows optical isomerism, yes, it shows optical isomerism. So this is not my answer, I will cancel it. Again, if you know, this is also octahedral and this can show geometrical isomerism, cis and trans is possible, right? It can show geometrical isomerism. So again, this is not my option. Now when you go for this square planar thing, now the square planar thing, you can always have a cis trans with this particular formula, then again it is showing geometrical isomerism. So this is also not my option. So geometrical isomerism is possible here. Now I am left with only one option, and that is my tetrahedral. Now here tetrahedral, it cannot show geometrical isomerism. Why? Because there is no relative change you can make. All the angles are perfectly 109.28, right? So you cannot make a relative change. So there is never a geometrical isomerism in this particular case, but it can show optical isomerism only when all the 4 ligands are different. But here the 4 ligands are not different. So it will also not show optical isomerism, and the question is asking who is not going to show isomerism. That makes my answer option number 1. So the next question, in the next question you see again it is coming from vesiper, hybridization, chemical bonding. So this topic is very important, right? If you are getting to know, this topic is very important. Frequently questions are coming, right? In one paper they are asking 2 questions, right? So let us see. Now if you count the steric number, you have to go the steric number way. Now the steric number will be what? How many sigma bonds you can see? 5 sigma bonds you can see, and there will be no lone pair. There will be 0 lone pair. So the steric number is 5. If the steric number is 5, then I just told you that hybridization will be sp3d. So please people, please try to understand, this hybridization is favorite, right? So you have to do a lot of questions on this hybridization. Now what is the geometry? It is trigonal planar, right? 3 bonds or 3 orbitals are in one plane, and 1 orbital perpendicular coming out and 1 orbital perpendicular going down or going inside. Now there are equatorial positions and axial positions. What is the order for equatorial positions? First you are going to place lone pairs. There isn't any lone pairs. Then what is the second preference? You have to put the multiple bonds there. Who is going to form multiple bonds? Oxygen is going to form multiple bonds. You are going to put the oxygen atoms here, and remaining fluorine atoms will be placed here. And this is how my molecule will look like. And this geometry or the structure is trigonal by pyramidal. Now when you know about this, you strike the other one out. This cannot be my answer. Now we will focus on the other one. That is this particular thing. Again we are going to do the same thing. We are going to find the steric number. Now what will be the steric number? 5 sigma bonds, and how many lone pairs? You put this minus charge. This is Xe5 minus. You put the minus charge on the central atom to quickly find out the number of lone pairs, and you will see there will be 2 lone pairs, which makes the steric number 7. Now if the steric number is 7, what hybridization people? It is sp3d3. And how does sp3 hybridization looks like? The 5 orbitals will be placed in a plane. When you join them, it will look like a pentagon. They are all in a plane, and 1 orbital coming perpendicular out. Let me show it with a different color. 1 orbital coming out of the plane perpendicular way, and 1 orbital going inside the plane in a perpendicular way. That means these red orbitals are placed at an angle of 180 degree. One is coming out and one is going inside, right? Whereas these 5 purple bonds or orbitals are in the plane of the screen, right? Now we have 2 lone pairs, and what does vesiper tells? Lone pair creates more repulsion, and therefore we need to place them at minimum repulsion. Now that minimum repulsion can be achieved when you place them directly 180 degrees. So one lone pair you place it here, other lone pair you place it here, and remaining all the fluorine atoms you place it here. And when you do, you will not count the lone pairs into your shape. The shape will look like a pentagon. The shape will look like a pentagon, and pentagonal planar will be the answer. So the first one has to be pentagonal planar. The first one is pentagonal planar, and we have 2 similar options like that. right? There may be something, some error when happened with our students when they were narrating the question, but the answer will be pentagonal planar for this particular one and trigonal bipyramidal for this particular one. So, that makes my answer either 1 or 2, both are same. So, you can follow any one of them. So, the next question is again very basic. This is directly people from NCERT. This is directly from NCERT. If you have gone through your NCERT, then this has been directly copy paste from NCERT, right? And little bit of physics knowledge is good, then also you can do it, right? So, this can be gone by elimination. Say for example, we have 2 ion, Coulomb's law we know. So, the potential energy is inversely proportional to R. So, that makes my answer for 1 as A. For 1 as A, where do I find 1 as A? I have 1 and 2, so I will strike off 3 and 4. 3 and 4 cannot be my answer. Now, what about dipole? This is physics. You have learnt in physics that the potential energy for a dipole is inversely proportional to R cube, So, that makes 2 matches with C. If 2 matches with C, then where I have 2C, I have here 2C. So, I will reject this 2 option also. That leaves me only option number 1, which is my answer. Now, see people, without knowing London dispersion force, I am getting to the answer. This is what they want, because for London dispersion force you cannot solve it, right? That is why they have given the options very cleverly. Now, if you go through your NCERT, it will be written there, London dispersion force is inversely proportional to R to the power 6. So, that means my answer is 1. Go by elimination, you eliminate 3 options, you are left with what? Only 1 option. That is the most intelligent way to approach the paper. Now, next question is again from your coordination complex and CFSE. You can say it is from CFSE. So, let me do a little bit of research on it. Okay. Now, lambda A, lambda B and lambda C, these are the wavelengths of the light absorbed. These are the wavelengths of the light absorbed by these A, B and C. A, B and C. Now, for the time being, if you follow their structures, all of them will be octahedral, correct? Yes. So, there will be some kind of splitting of the d orbitals, and the splitting will result into something like this. Splitting will result into something like this. Now, this gap is called between the splitted d orbitals, it is called CFSE. Crystal field splitting energy, or we can sometimes also write it delta, and it is octahedral complex, we write it delta O. Now, if this gap is more, the wavelength that will get absorbed will be less, because if the gap is more, that means what? This difference in the energy, this delta E is more, and if delta E is more, the wavelength that needs to be absorbed has to be less. So, this is what we are going to use it. Now, when this is more, when the ligand is a strong field ligand, Now, if you see out of all these options, you might see that this one has fluorine. Fluorine is the weak field ligand, and therefore, in case of fluorine, this will be the smallest. And if this will be the smallest, out of the 3 options, lambda has to be relatively bigger in case of B. So, I need the lambda for B to be the greatest, and that is where I will look into the option. That means for B, the lambda has to be the largest, relatively speaking. So largest lambda is C. Right? Largest lambda is C. So, it should match with B. Lambda C is matching with B. So, either 2 or 3 is my answer. So, I will reject 4 and 1. Now, if you compare this and this, we also know that NH3 is a strong field ligand. except for Fe plus 2 and Mn plus 2, right, except for Fe plus 2 and Mn plus 2. So, here we have Fe iron with that, so it will be little bit weak, and if it will be little bit weak, this will be little bit less, and if it will be little bit less, lambda will be little bit more. So, lambda will be little bit more for this particular fellow. So, next, which is the lambda? Next lambda is this. So, it should match with A, it should match with A. So, lambda B should match with A, right, and therefore, my answer becomes 2, and therefore, my answer becomes 2. Simple logic. What is the logic? You have to see the ligands. If the nucleophilic nature of the ligand increases, the gap between the splitted d orbitals will increase, and if the gap is more, then which photon they will absorb? They will absorb a photon of lesser wavelength or greater frequency, right. So, that is the key here. So, next question. So, the next question is simply the way you make pickles, right. They are asking how to make pickles, right. So, again a simple and easy question. So, a mango, this is a mango, say for example, my drawing is not very perfect, and you are keeping it into a solution where the concentration of this salt, with a concentrated salt, that means here is some salt, here is some salt solution, here is some salt solution. So, where is the amount of water will be more? So, this is a concentrated salt solution. So, here salt is more, water is less. So, where will be the water more? Water will be more here, water will be more here. So, now water will come outside, water will come outside, and as a result the mango is going to shrink, the mango is going to shrink. So, if a mango shrink when kept in a concentrated salt solution, then which of the following is taking place? This is what? This is the movement of the solvent particles we study in solution chapter, and it is nothing but osmosis. It is nothing but osmosis. So, very straightforward answer. Next question. Next question is from thermodynamics, right. So, here they are asking you heat of combustion of ethanol to give CO2 and water at 27 degrees centigrade and 327 kilocalories. Now, we will draw the ethanol. Okay, this is my ethanol. I guess everybody is comfortable with ethanol. And what is the state of ethanol? That is important, people. Ethanol, the state is liquid. Everybody knows this. Now, we are reacting with oxygen. Now, oxygen is a gas at this particular temperature. Now, this reaction is called combustion. So, what you are going to get? You are going to get CO2 gas, right? And look at the temperature, it is less than 100 degrees centigrade. So, whatever water you are going to get, it will be liquid, it will be liquid. Now, can you balance it? Can you balance it? Yes, we can balance it. I think I require a 2 here, right? If I require a 2 here, then it will be 3. Then it will be 3. Now, this is a chemical reaction, people. It is happening at a constant pressure and it is happening at a constant temperature. Now, they are giving this heat of combustion, they are giving this heat of combustion. Now, this heat is the heat exchange at constant pressure, and the heat exchange at constant pressure is equal to delta H. So, they are giving the value of delta H. Now, what is the relation for a chemical equation? Delta H is equal to delta U plus RT delta Ng, RT delta Ng. Now, what is the delta Ng for this particular reaction? That is, you only look for the gaseous species. The right hand side it is 2, left hand side it is 1. So, delta Ng will become minus 1, delta Ng will become minus 1, right. This is already given to you in the question, people. This is this value, this is this value. Put it with sign, you will get it automatically in sign. R in calories, you have to take the value of R as 2. The temperature in absolute scale, it is 300. Right, you put the data there and you are going to get delta U, because they are asking delta U, how much heat is evolved in combustion at constant volume. The heat involved at constant volume is nothing but delta U. So, you do a little bit of math on it, you put the data, you are going to get delta U, and delta U will come out to be this much in calories, because the question says in calories, right. So, next question is from electrochemistry as well as from equilibrium. Multiple concepts are required. So, people, what you need to do, first of all, the key here is to manipulate this given reactions and obtain the reaction that has been asked. So, what you can do there? You see, the 1 is okay, but if you reverse the second reaction, how it will look like? Copper plus 1, copper plus 2, and this is my electron. Now this is my first reaction, and now I have reversed it and I am saying it third reaction. Now if I add 1 and 3, 1 plus 3, 1 plus 3, what will I get? I will get 2 Cu plus, right, and electron will get cancelled out. I will get copper and I will get copper plus 2. Now this is a disproportionation reaction of copper. It is given in your D block. If you see the NCERT clearly, this reaction is given in your D block NCERT part. Now they are asking you about this. So first of all, you have to calculate the E naught of this one, So what you need to do, whenever you add and subtract reactions, you have to add their extensive properties. Say for example, I write down the delta G naught. Delta G naught for this particular reaction, it will be minus N. What is N? 1. What is E naught? It is given. E naught is given to you, that is 0.52 into F, right. Now I want to write down the delta G naught of this particular reaction. So this is delta G naught. Again we see a 1 electron, so 1 will come, but what will be the E naught? For this reaction it is 0.16. Now I have reversed the reaction, right. I have reversed this particular reaction, so it will be minus 0.16. And here if I want to write down the E naught of this particular reaction, what I will write it down and how I will write it down? I am going to write down the E naught by simply, let's suppose the delta G naught of this particular reaction, I will simply write delta G, this value, right, this value I am calling it delta G naught 1, let's say for example delta G naught 1, and I am going to add delta G naught 2, and I am going to add delta G naught 2. And from here I am going to get the E naught for this particular reaction. Now once I get the E naught for this particular reaction, it becomes very easy. We can write delta G naught is equal to minus N E naught F, which is also equal to minus RT ln K, This E naught value, you put it here, you put the value of N, F is already known to you, R and T is okay, you can get the value of ln K. Now when you will solve it, you will get the answer option number 1, that is 144. There is no options, people, it is 144 you are going to get, because they are wanting the answer in this particular format. And that is why I did not convert this expression into log, right, because ln K is here, right, and they want you in this particular format. So please keep in mind the answer will come here 144. Next question. The next question is very easy also and very difficult also. Difficult means it will consume time, right. So you need to be very alert. I am giving you both the solutions, right. So first of all, in a saturated acyclic compound, first of all it is a mole concept question, right, mole concept stoichiometry question. Acyclic compound, the mass ratio of carbon is to hydrogen is 4:1, and the mass ratio of carbon is to oxygen is 3:4. This is what is given in the question, right. So one way people will approach this question in this particular way, which I am not interested, but I am giving to you because this way it will take time. Suppose you assume that particular compound CHNO and assume the molecular formula XYZ. What are these XYZ? These XYZ are nothing but some integers, right, some positive integers. Now this is the molecular formula. Now you apply this logic here. The molecular mass you can calculate as 12x plus y plus 16z, right. Now, what is the mass of carbon? The mass of carbon is 12x, right? And what is the mass of hydrogen? The mass of hydrogen is y. Now, this ratio they are giving as 4:1. And what is the mass of carbon? The mass of carbon is again 12x. What is the mass of oxygen? The mass of oxygen is 16Z. And this is also given as 3/4. It is also given as 3/4. Now, with this you can get the value of x by y and x by z, and from there you can get x is to y is to z. Now, once you get this x is to y is to z, you know the empirical formula and you can solve the problem. But what I will do, I will use some kind of common sense so that we can do the problem easily, because we have to do it in 1 or 2 minutes, right. So, definitely this way they are not asking. Say for example, this particular information I take it, mass ratio of carbon is to hydrogen is given as 4:4/1, and the mass ratio of carbon is to oxygen is given by 3:4. Now, what I am doing is that I am multiplying this one by 4. So, what it will become? 12/16. Yes, we can do 12/16 is also same as 3/4. Yes. Now, here also what I am doing, I am multiplying by 3, both numerator and denominator. I will end up what? 12/3. I will end up what? 12/3. Now, these are mass ratio, people. Why I did this? I did this deliberately. Why? Because the atomic weight of carbon is 12 and the atomic weight of oxygen is 16, right. So, that is why I did this. Now, if I use this into the information, then I straight away get the empirical formula something like this, because if this is the ratio, from this empirical formula, how many hydrogens are there? 3. Because 16 gram means what? 1 oxygen atom. So, oxygen atom will also be 1 and carbon atom will also be 1. So, this is the empirical formula I directly get. This is the empirical formula I directly get. Now, what they are asking? Now, it is easy. Find the moles of oxygen required to react with 2 moles of the compound to give CO2 and water. Now, obviously 1 carbon, 3 hydrogen and 1 your oxygen, this will have to be converted into the molecular formula. Now, let us see the molecular formula. Here the ratio is not matched. You see the ratio carbon is to hydrogen, that is 4:1, and still the mass of carbon is to oxygen, it is 3:4. This is also valid, right. This is also valid. Now, you multiply this one by 2, I get C2H6O2. I get C2H6O2. Now, if I react this particular compound with oxygen, I am going to get CO2, I am going to get H2O, I am going to get H2O. Now, if I balance this one, I think I require a 2 here, I require a 3 here, 4 plus 3 7, 4 plus 3 7, and 7/2, 4 plus 3 7 oxygens in the right hand side, 2 oxygens you see here, I require a 5 here. I require a 5 here, that means 5/2 will be here. Now, I require a 5/2 here. Now, if I multiply the overall equation by 2, so here 2 will come and here this 5 will remain. So, 2 moles of this particular compound will require how much? Will require 5 moles, will require 5 moles. So, 5 is the answer. Now, next question. This next question is again very easy, from atomic structure, photoelectric effect, very basic question, people. What is the equation that you have to write down? Whatever frequency you are giving subjecting to the metal surface, that means this much. This is the incoming or incident packet of energy. This is the incoming or incident packet of energy. Now, this is equal to work function plus kinetic energy maximum, This is simply energy conservation. This is the incoming energy, right. Out of that, this much is utilized to come off, to break off from the atom, and whatever now he is having, this will be like its extra kinetic energy. Now, metal, the work function is given as this much. So, phi value is given. This is my phi value. This is my phi value. Now, the wavelength is given as 300 nanometer. A metal having a work function this much is subjected to a light having a wavelength of 300 nanometer. So, that means incident light is given. Now, you have to convert this into Hc by lambda. Now, this lambda is given as 300 nanometer. The maximum kinetic energy they are asking the maximum kinetic energy, but you have to take care, the unit here is joule. So, you have to use all the SI units, right? H value is given here, C value is also given. You put the value of H and C, lambda is also given to you, this is lambda, this phi is also given to you, right? And you put the value of all these things, you are going to get the kinetic energy, and if you order it in this format, then you are going to get 2 into 222 into 10 to the power minus 21 joule, right. So, the answer here becomes 222. Now, next question. The next question here, the oxidation state of the transition elements of the compound K2Cr2O7, KMnO4 and K2FeO4 BXYZ. Again, this question is from redox, or also you can consider it to be a D block question as well. Now, very basic and very easy question. Oxidation state, of course, they are asking about the highlighted one. Say for example, they are asking about chromium, they are asking about manganese, and they are asking about iron. Now, you have to work it out. The oxidation state here, you know it is 6, here you know it is what, 7. These are very basics, everybody knows. And what about this fellow? Let me see this fellow. What is this fellow? I leave out the 2K, that means FeO4, it will be minus 2, it will be having minus 2. Now, if I assume the oxidation state of iron to be X plus 4 into minus 2 is going to give you minus 2, 4 to the 8, right. Minus 8, when it will go to the right hand side, X will come out to be plus 6, So, you can add this plus 6 and plus 7. So, the answer will come out to be 19. Yes, with this I wrap up the discussion. Hope you have enjoyed and you have liked it. Please do like and share, right. And of course, I will be looking forward to meeting us in our Sri Chaitanya program. It is the best in the country regarding your IIT preparation is concerned. So please do join us for our expert guidance on our online programs as well as on offline programs. Thank you very much.